Hello class, in this lesson we're going to learn about equations of circles. So what figure do we get if we draw all the points that have a distance of 5 from the origin? Well, we get a circle, right? A circle set of all points equidistant from a given point. And we want to figure out what are points that lie on this circle. And so for now, let's just stick to lattice points, where both coordinates are integers. What are 4 that are pretty easy to find? So where does the circle intersect the axes? Well, we have 4 of those points. 0, 5, 0, negative 5, 5, 0, negative 5, 0. But those aren't the only lattice points. What other points have a distance of 5 from the origin? Let's see, we have this point here has the coordinates 3, 4. And this point has the coordinates 4, 3. And we have corresponding points in the other quadrants. Now, how can we be sure that these points truly are a distance of 5 from the origin? So remember, these are diagonal segments, so it's not easy to find their distance or their length. But in order to do that, we can use the Pythagorean theorem, or the distance formula. In this case, let's stick with the Pythagorean theorem. And let's see, our legs here are 3 and 4, and we want to show that the length here, the hypotenuse, is 5. And we get 25 equals 25. Now, every point on the circle has to satisfy this process. So if we picked any point on the circle, it would have the coordinates. If we didn't know what they were, we could say they're x and y. So instead of 3 and 4, we could plug x and y into that equation, and we get an equation for the circle in general. So this circle's equation is x squared plus y squared equals 5 squared. So any point we pick on the circle has to satisfy this. Here's a different circle. It has the center 2, 3, and a radius of 5. So how does this compare to our previous example? Well, they have the same radius, but the centers are different. Can we say the circles are congruent? Yeah, they have the same radius, and we can translate one to the other by using a translation. So we want to move the center from 2, 3. I'm going to translate it to 0, 0. And so what effect does this translation have on all the points on our circle? So if we translate this 2, 3 to the origin, we've subtracted 2 from x and 3 from y. And here's a point on our circle, 5, 7, and when we translate it, it becomes a point 3, 4. Right? 5 minus 2 is 3, 7 minus 3 is 4. So that holds for all of the points on our circle. And so if we don't know what point we're translating, we can just say we have x minus 2 and y minus 3. And if we plug this into Pythagorean theorem like we did before, we get an equation for the circle. Quantity x minus 2 squared plus the quantity y minus 3 squared equals 5 squared. And any point we pick on our second circle has to satisfy this equation. And so what do the numbers represent from our problem? Well, the 2 and the 3 represented the center, and 5 the radius. Now, what if we didn't know what the center of our circle was? What equation could we write for it? Well, the radius is still 5, so the 5's not changing. But instead of minus 2, we're going to have minus a, because we don't know what the x-coordinate is of our center. Instead of minus 3, we're going to have minus b. Okay, let's take it one step further. What if we didn't know what the radius was? Well, instead of the 5, we would plug in an r there. And this gives us the general formula for the equation of a circle. So very important. Quantity x minus a squared plus the quantity y minus b squared equals r squared. So let's apply what we've learned. We want to write an equation for a circle with the center 9, 0 and radius 7. So try that on your own, and I'll show you my solution. So we write down our formula. And a in this case is 9, and b is 0, and r is 7. And we usually want to simplify this a little bit. We don't want to get rid of the squares with the exponent. I'm sorry, the squares with the variables. But we can simplify this. 7 squared is pretty simple. And we can simplify this binomial here. Y minus 0 is just y. So this is a better way to write that circle's equation. So quantity x minus 9 squared plus y squared equals 49. What about this circle? Try writing its equation, then I'll show you my solution. So the center is -2, 4, and the radius is 2. So we plug into our formula. And remember, we're subtracting a negative, so the sign's going to change. It's going to be x plus 2 on the inside. That equals 4. So if you don't like this step, you can skip it. You could just go straight to x plus 2. Just remember, you're always putting the opposite sign for the coordinates of the center inside the parentheses. So now we have the formula, or we have the equation of a circle, and I want to figure out its radius and center. So try that, and I'll show you my answer. Remember, we take the opposite signs for the coordinates of the center, and this is the radius squared. So the radius squared is 81. The square root of that is 9. And the center is going to be -12, 4. Right? We switch the signs here. Here we have the center, and we know a point on the radius, a point in the circle. So there's a radius that has endpoints that are this center, and the other endpoint is this point on the circle. And let's see, how do we figure out the radius then? Well, we can plug into our equation. Right? We know this is the center, so we can have -3 and a -10 on the inside of the parentheses. And we don't know the radius, but we know a point on our circle. We have 12, 12, so we can plug in 12 for x and 12 for y, and then solve for r. Right, so this is pretty much what we were doing with Pythagorean theorem before. Let's see, so we get 81 plus 4 is r squared, so the square root of 85. So what's the equation of the circle? So instead of r, we're going to plug in the square root of 85, but the squared and the square root are going to cancel out, and we just get the quantity x minus 3 squared plus the quantity y minus 10 squared is 85. And here we have the endpoints of a diameter. So what's the center of the circle going to be? Well, if these are the endpoints of the diameter, then the center has to be its midpoints. So just find the average of the x coordinates and the y coordinates, and we get the 0.78. What's the radius? Well, we know the center, and we have a point on the actual circle. We could use either point here. And what's nice here is that we have a horizontal radius. Right? The y values are both 8. So we just subtract the x values, and we get that it's 10 units. If we had a diagonal here, if it didn't work out nicely, then we could just use the distance formula or Pythagorean theorem to figure out the radius. Or we could have used the process we did in the previous example. Lots of ways to do it. So what's the equation of the circle? Well, we know the center is 7 eighths, and we know the radius is 10. Okay, and 10 squared is 100. In this lesson, we learned about equations of circles. Thank you for watching this video.